global warming, the continuous increase of our planet's overall temperature. This phenomenon is caused by the increasing quantities of carbon dioxide being released into the atmosphere by human activities. CO2, however, does not simply remain in the air. Portions of it are absorbed by the oceans. While the ocean is able to efficiently absorb around 30% of the carbon dioxide in our atmosphere, our excessive CO2 production triggers a problematic phenomenon: ocean acidification. This process begins when excess carbon dioxide in the air starts to dissolve in ocean water. This reaction produces an aqueous carbonic acid, which further dissociates in the water by losing H plus ions and producing hydrogen carbonate. These excess H plus ions are the ones that are particularly damaging to marine life, since a higher H plus concentration means a lower overall pH, which makes the marine environment more difficult to live in, but we'll discuss that more later. Since there is an excess of carbon dioxide being produced and absorbed by the ocean, an imbalance can be seen in the chemical equation on the screen. Le Chatelier's principle states that any imbalance should be equalized by a shift in the direction of the equation. Simply put, the more carbon dioxide dissolved, the more carbonic acid and H plus ions are produced, making ocean water more acidic. While humans don't really feel or see the phenomena, the rising acidity of our oceans significantly affects various marine organisms and the environment they reside in, both directly and indirectly. Ocean acidification can directly impact the development and survivability of marine calcifiers such as mussels, echinoderms, and corals. These organisms rely on carbonate ions present in the water by combining it with calcium to form their calcium carbonate shells and exoskeletons, which they use for protection and support. The increasing rate of ocean acidification makes carbonate ions less available in the water. This is because they bond with excess H plus ions that were mentioned earlier. With less carbonate ions available for ocean calcifiers to use, their shells will eventually weaken and thin. A specific example of this would be corals. Increased acidity can cause these organisms to have difficulty in building up their own bodies and even dissolve already existing structures they have. Ocean acidification has also been shown to alter the behavior of some marine organisms. Clownfish, for instance, have been shown to wander farther away from the safety of the reefs the more acidic water conditions get. By altering the behavior of species like this, ocean acidification can indirectly affect the ecosystem's food web, causing many different species to suffer from this drastic change. Finally, ocean acidification has also been shown to have negative effects on phytoplanktons. Phytoplanktons are the foundation of the whole marine ecosystem. A study found that increased seawater acidity reduced Antarctic phytoplankton's ability to build strong cell walls, making them smaller and less effective at storing carbon. With the rapid rise of ocean acidification, we could see this effect worsen before the end of the century. Now let us get closer to home and discuss the effects of ocean acidification in Philippine waters. The Philippines ranked 7th out of 187 countries in Oceania's Ocean Acidification Risk Report, which isn't surprising as the country resides in the Coral Triangle and has an estimated 26,000 square kilometers of coral reef area, the second largest in Southeast Asia. If ocean acidification is able to reach and damage these reef systems, the reefs themselves and the species that reside within them would suffer immensely. In addition, ocean acidification could also have a huge impact on the fishing and aquaculture sectors of our country. In 2021 alone, these sectors employed over 1 million Filipinos and made up roughly 12% of the country's gross value added. In fact, reef fish account for around 20% of the catch in this country. Fish is also the most consumed animal protein by Filipinos. Many Filipinos rely on the fishing sector, and ocean acidification's impacts could deal a heavy blow to the industry and leave many Filipinos hungry. An example would be the H. asinina larvae, or the donkey's ear abalone, a species exported by the Philippines. A study confirmed the negative effects of the ocean's reduced pH on the species' survival, and humans would start to feel its implications when the Philippine abalone economy is hit. Another study looked at shallow vent habitats in Batangas. Hydrothermal vents are a natural source of carbon dioxide. Even though there are some corals that were able to survive the low pH conditions, the researchers suspect they only did so with physiological causes like weakened exoskeletons. Not all hope is lost though. In 2021, Favites colemani, a common reef-building coral species from Bolinao, was placed in near-future conditions. That is, if global warming and ocean acidification continue to develop rapidly, and showed sustained photosynthetic competency despite the decline in growth rate. Though it experienced lower growth rates, it would definitely still survive. With the effects having already been discussed, we should then refocus and discuss why ocean acidification is happening. While carbon dioxide in the atmosphere is a completely natural process, it's the over-emission by anthropogenic activities that throw off the natural balance. Primarily, the excess atmospheric carbon dioxide comes from the usage of fossil fuels, which have become an integral part of what makes the world go round, as it is used as energy through heat and electricity. This is further exacerbated by excessive land use and deforestation. As more land is urbanized, more trees will also be consequently cut down. These areas then become carbon sources and can no longer help absorb excess carbon dioxide in the air. Both these factors have caused the amount of carbon dioxide released into the atmosphere to increase exponentially throughout the years. With all that being said, what can we do to solve this problem? Well, researchers from UP Visayas in Iloilo proposed the following policy processes in the Philippine context. The first solution would be public awareness and research, spreading knowledge on ocean acidification just like this video. We need a diverse media spread of this phenomenon to make people more aware of its damaging effects on our oceans. Moreover, we need more research about Philippine ocean acidification specifically, because we need to know the area-specific damages it can do to our waters. In researching for this video, in fact, we found it hard to find ocean acidification research set in our country. Second is to create international socio-scientific networks to help build site-specific, flexible, and adaptive communities and resilient ecosystems. We should help specific areas that are much more vulnerable to ocean acidification, especially coral reef areas. This can be done through international networks of expertise. As experts on ocean acidification would help collect the necessary data to help formulate appropriate courses of actions. Third would be to create new legislation or policies to integrate large ecoregions or ecosystems to existing governance and management systems. National and local governments should coordinate to alleviate ocean acidification through legislation and proper execution of relevant and region-specific laws. Monitoring and impact assessments should also be a joint effort. Finally, we must empower local communities. Policymakers should partner with local communities, especially those that are more vulnerable to ocean acidification. These local communities would best understand the situation and the possible solutions that they could do in their own area. By partnering with an LGU, they would have ample resources and proper management to effectively do these projects that could lessen their total carbon dioxide emissions. Thank you for watching this video. We hope you learned a lot about ocean acidification, its effects on our oceans, why it's happening, and how we can help battle it.